Hello everyone. Today we are going to start lecture 04 of class 8 mathematics chapter number 5, which is data handling. In this lecture we are going to talk about graphical method of representation of data. Now why do we need to represent the data graphically? We already learned how to represent the data in tabular form, and in that we learned about frequency distributions. There are two kinds of frequency distribution, that is the discrete and continuous. So why do we need graphical data if we are very happy with the frequency distributions? Because again, to read a data from a table and to see it on a figure, obviously the figure one will be more attractive and it will be more easy to read, right? Also, bar graphs and these type of data, that is the graphical data, makes it easier to draw conclusions as to whether the data is increasing or decreasing, or which is the highest observation and all about it, right? So again, in comparison to tabular form, graphical method is a bit easier to read. Now again, since we have two kinds of frequency distributions, we have two kinds of graphical methods to represent data. For discrete frequency distributions, we use bar graphs, and for continuous, we used histograms. So these are the two graphical methods. So the first one we are going to discuss is bar graph, right? So what is a bar graph? If we talk about the definition, then a bar graph is a bar graph is a graphical display a bar graph is a graphical display of data using bars of different heights, right? So we use bars of different heights to represent data. Now these height represents the frequency and a particular bar represents a particular type of data point, right? So bar graphs is a graphical display. Also, a bar graph is also known as bar charts. They are also known as bar charts, right? Okay, so it is a pictorial representation of grouped data, right? So you can represent data using bars or bar graphs, right? Now bar graphs are, since it is bar charts also, what do we mean by bars? Because we are also talking about the height, so there must be something called width of bar. So let me tell you, the width of the bar here remains constant. I'll show you the figure in a bit. So bar graph is a scientific way of representing data using rectangular bars, right? So in bar graphs, comma, we use, now what kind of bars are these? Are rectangular bars, right? In bar graphs we use rectangular bars to represent data. We use rectangular bars to represent data where the length of each bar is proportional to the value they represent. Right, that is the frequency. More the frequency, higher the length of the bar. That is the main purpose. Okay, what is the main purpose? To read the data so fast, so that a value of bar or the length of bar visually can represent the frequency. So if a bar is longer than another bar, then it must be having higher frequency. Okay, now important point to note here is that this type of representation, that is bar graph, is used mostly for discrete type of data, right? So bar graphs are used for representing frequency distribution of ungrouped data, or you can call discrete distribution. they are used to represent discrete distributions, right? So bar graphs are used bar graphs are used for representing the frequency distribution, distribution of ungrouped data, right? Frequency distribution of ungrouped data, right? So these are the basic definitions and properties of bar graphs. Now let me show you that how a bar graph look like. Okay, so a bar graph looks like this, right? So you can clearly see in this, these comedy, action, romance, drama, sci-fi, these are the types of movies and how many people like these type of movies. So these are the variates. So you can clearly see the width of each bar is same because we assign similar width to each value. That is the benefit in the discrete distribution, right? It is always used for discrete distribution, right? So in discrete frequency distribution we have only discrete values and we treat each value as of equal width. Now you can see the length of these rectangles, or you can see the height is actually depending on the frequency, right? Since 4 people like comedy movies, so its height is 4 unit. For romance it is 6. For drama it becomes only 1. Okay, this is nothing but 1. For sci-fi it becomes, that is science fiction movies, it becomes 4. So you can clearly see bar graphs. In the case of bar graphs, we have equal width but unequal heights or lengths because they depend on the frequency. So this is the best way of representing data. Now you can clearly see, just by visualization, you can clearly see that since more people like romance movies and less people like drama movies. So that is the main purpose of representing a data graphically, so that we can conclude things and we can actually find our data a bit interesting to read. Okay, so that is the main intention. Now let us talk about the second type of data, which is the histograms. Now what are histograms? So for example, let me show you that since bar graphs have singular bars, they had gap between them and they are of equal width. So who is deciding the width? We are deciding the width because each data point has same width, so you can decide any width according to your convenience. But in case of histograms are used for grouped frequency distribution, in which actually the width is decided by the class intervals, right? So at that bar graph, a rectangle was representing a particular data point, but in histograms the bar will represent a complete interval, right? So that is the basic difference between histogram and bar graph. I'll show you the diagram, but let us start by writing the definition of a histogram. So what is a histogram? A histogram or frequency histogram is a graphical representation of frequency distribution. Graphical representation of what? Of frequency distribution in the form of rectangles. Frequency distribution in the form of rectangles with class intervals. You can clearly see it is frequency distribution in the form of rectangles, that is bars with class intervals. So in this case we will not have discrete data, we have interval with class intervals as basis. You can clearly see the base, that is the width, is the class intervals, and again here also height will depend on the frequency, and heights proportional to corresponding frequencies. Heights proportional to heights proportional to corresponding frequencies such that there is no gap between any two successive rectangles. So you can clearly see what is a histogram. Histogram is a graphical representation of again frequency distribution in the form of rectangles in which the bases are actually proportional to the class intervals and the heights are proportional to corresponding frequencies. Okay, so such that there is no gap, because you can clearly see the intervals are continuous, right? If 10 to 15, then the next interval will be 15 to 20. So there is no gap between the bars. You can clearly see in the case of bar graphs, there is a gap between comedy and action, and again this gap depends on you. You can take any gap. The bit should be same, but in this case there would be no gap, right? So what is the histogram? Again, histogram is a two-dimensional graphical diagram, right? So why histogram is used? Again, it is used for grouped frequency distribution, right? So let me show you how a histogram looks like. So this is an example of histogram. You can directly see that this particular bar represents 0 to 10, then this represents 10 to 20, then this 20 to 30. You can clearly see these are intervals, right? And there is no gap between the rectangles or bars. Also, the heights of rectangle is actually depending on the number of employees in this case, which is the frequency. So you can clearly say that histogram is used for a continuous grouped frequency distribution. Right. So histogram is used for continuous grouped frequency distribution. So you can clearly see bar graph is for discrete and histogram is for continuous distribution. Right. Now let us take some questions and try to answer that how do we make a histogram and how do we actually plot it. Right. So let us take a question. Now again, for solving a question, and before solving a question we need some algorithms. Okay, if you want to read them, they're very easy. Otherwise I'll show you how to actually make a histogram, right? We'll talk with the help of diagrams. So before solving a question, you can actually have an algorithm. What is algorithm? It is a series of steps used to solve a questions, right? So again, it is very basic. Take a graph paper, draw two perpendicular lines, that is the x-axis and y-axis. Take the horizontal line as x-axis and y-axis. See, choose a suitable scale, that is 1 centimeter on the green graph paper will represent some units. Similarly on y-axis it will represent some units according to the frequency. If you have highest frequency of 100, you should take 1 centimeter equals to 10 units, so that 10 blocks will represent the entire graph, right? So it is again up to you. Construct rectangles with the class intervals as bases and respective frequencies as heights. So that is we have already studied. Now that is also the same thing, that scale for x-axis may not be the same as the scale for y-axis. Also in the previous classes also we have already learned that on x-axis you can take different scale according to the data on x-axis, and if the data is very large on y-axis the scale should be more, right? The selection of scale depends upon our convenience and the type of data. That is, the entire data or the entire graph should be fitted into your page, okay, or the graph. So these were some basic algorithms. It is nothing, right? So let us take a question and try to solve it. Now given below is the frequency distribution of heights of 50 students of a class. Class intervals are these and these are the frequency. Now we have to draw a histogram to represent the above data. Now it is very simple. How do we approach the question? First of all, see, the data is not starting from 0. So 0 to 140 we have to use a symbol called kink. So in this way you can use a symbol called kink, right? So you can start your x-axis directly from 140, right? And this is 0, this is your y-axis. So you can clearly see that your data, this particular point will be called as kink, right? This is origin, this is y-axis, this is x-axis. So the first thing which you have to note is that you have to see that whether your data is starting from 0 or something else. If it's starting from 140, this kink will represent the data from 0 to 140 because we have no frequency about it, right? So it is a frequency distribution of height of 50 students, so the sum of frequency should be 50. Now we have to draw a histogram. Again, the interval is 5, so now that is also up to you. See, there are 5 interval, class size is 5, so you can represent that 1 centimeter on x-axis will represent 5 units. So the bar width will be 1 centimeter. You can also represent that 2 centimeter will represent 5 units. That is up to you. Okay, so that will be the scale on x-axis. On y-axis, maximum frequency is 18. Right, so you can easily take that 1 centimeter equals to 2 units. That is up to you again. Now let me show you what a histogram will look like for this particular question. So the histogram will look like this. Okay, so that is the histogram for the given question. You can clearly see we have used a simple kink to represent from 0 to 140, the data from 0 to 140, because we do not have any value of frequency, right? From 140 to 145, since the value was 8, so we have written 8. From 145 to 50, the value was 12. So we have written 12. So the height of rectangle became 12. You can clearly see the width has been taken to 1 centimeter is representing 5 units. One big division equals to 5 units on the x-axis, or on the y-axis, one big division or the 1 centimeter. These are the block of 1 by 1 centimeter, right? So this 1 centimeter is representing 2 students. So you can clearly see the scale on x and y-axis is different. On the y-axis we are representing 5, class size of 5 with the help of 1 centimeter, but here for 1 centimeter we are using only 2 students. So this was the entire graph. Now what we have done is that the class limits are represented along the x-axis on a suitable scale. Now what is that suitable scale? 1 centimeter equals to 5 units, right? On a suitable scale, and the frequency, that is what algorithm has also said, right? So class limit should be the base and frequency should be the height, and frequency along the y-axis on again a suitable scale. So what is that suitable scale? You can clearly see that suitable scale is 1 centimeter equals to 2 students. Okay, so that is how we represent the histogram. Also you can clearly see that taking the class intervals as basis and corresponding frequency is the height, the rectangles can be constructed to obtain the histogram of given frequency distribution. So this figure is the given frequency distribution, and you can see the given histogram of the given question. See, this is the frequency, or you can also write the number of students, and there is the class interval. Okay, so this was all about this particular question. It is that easy to construct a histogram. Now let us talk about another question so as to understand this method more deeply. Now this question simply says, for this particular question we have number of workshops organized by a school in a different year or during the last 5 years are as follows, right? So number of years are there and number of workshops are there, right? So we have to actually draw the diagram, and we have to find that how actually these data are represented on the histogram, right? So how can we find this data? There are the years. Now see, intervals are fixed, continuous intervals. There are number of workshops, right? So we have only 25 workshops. For 96 to 1997 we have 30 workshops. For 97 to 98 we have 42. During the year 1999-2000 we have increased to 65 workshops. So it is a data of years is to number of workshops. So number of workshops is working as frequency, and years are actually working as the class intervals. So we have to draw a histogram to represent the above data. So in the last 5 years we have organized number of workshops, right? So how do we start? Again, the first step should be that the data is not starting from 0. So from 0 to 1995 we have nothing. So we'll use the symbol kink. So this will be our graph, right? This is the origin. This is again x-axis. This is again y-axis. So that should be remembered. Also, the number of workshops are 25. So you can clearly see the maximum number of workshops are going to 65. So you can take the scale accordingly. So the graph or the histogram of this particular question will look like this. Now you can clearly see on x-axis, this symbol king is used because the data is not starting from 0. Again, the scale on y-axis has been taken as 1 centimeter or 1 big division is equals to 5 workshops. So you will have to get 13 lines or the 13 blocks to represent 65. That is well within our limits, so we can do that. On again x-axis, we have taken 1 year as 1 centimeter. Also, you can take 1 centimeter equals to half year or 2 centimeter equals to 1 year. Then that would be more wide. Okay, you could have also made data like this. This is the king, and then instead of this much thin, you could have gone for this much width, right? So you would have taken this as the 1 unit. So that is again up to you. You can do that, right? So this is the data. Now on the x-axis we have represented the number of years, and on the y-axis we have represented the number of workshops. That is the frequency, that how many workshops are being organized in a particular year, right? So on x-axis king is used. So this is the data. One more thing to note here is that these are years. Okay, so that is up to you if you want to write these extra data. Again, you can clearly see that we have written 70, 75, 80 because we already knew that there will be no use, but you could write that. Similarly, you could write from 2000 to 2001, 2001 to 2002, but because you do not have any data, so you do not have to represent any kind of rectangle here. So we have data only for these 5 intervals, these 5 years we have represented. Again, you can see how easy it has become to read the data. That you can clearly see that maximum number of workshops has been organized from 1999 to 2000. So that is the power of graphical representation of data. Now these were the cases where we have to construct the histogram with the given data. What if we are given a histogram? So let us talk about this particular question in which a histogram is given, which tells us the number of literate females in the age group of 10 to 70 years in a town. Now there are some set of questions which are asked based on this particular graph. Now this type of questions are very common, which usually come in exams, in which we are given a graph and we are asked some questions, that is what is the class width, what is the lowest frequency, and similar type of questions, that which group has the highest frequency. Okay, now in this case frequency is the literate females, okay, and the class intervals is basically age group. So we can clearly see that on the side of frequency we have literate females, number of literate females, and on the side of class intervals we have age group. So the first question is, write the age group in which the number of literate females is the highest. So we can clearly see that in the age group 20 to 30, the length of this particular rectangle is the highest. This bar is highest. So in this particular histogram, 20 to 30 is the age group which has highest number of literate females. So the answer is 20 to 30. Okay, it has asked us the age group, that is the class interval, right? In the second question, it is asking what is the class width. Now clearly you can see that in a histogram class width is generally constant. Okay, so we can clearly see that class width is 10 to 20, 20 to 30, 30 to 40. All of these have a class width of 10, right? How do we calculate class width? Upper limit minus lower limit of a class interval. So 30 minus 20, it is also 10. 70 minus 60, it is also 10. What is the lowest frequency? Now what is frequency? That is literate females. So we can clearly see that the age group 10 to 20 has the least number of literate females, that is 320. So that is the least frequency, or you can say lowest frequency. What are the class marks of the classes? Now class marks are basically midpoints of a class interval. Okay, so for 10 to 20 the class mark would be 10 plus 20 by 2, that is 15. For 20 to 30, the class mark would be 20 plus 30 by 2, that is 25. For 30 to 40, class mark would be 30 plus 40 by 2, that is 35. For 40 to 50, it would be 45. You can clearly see it is the midpoint of class interval. For 50 to 60, it is 55, and for 60 to 70, it is 65. Now in which age group literate females are the least? So you can clearly see lowest frequencies of age group 10 to 20 we have answered in the third part. So we can clearly see 10 to 20 is the age group for which we have least number of literate females. So in this way you can solve this question. These type of questions are very common and very easy to do. So in this lecture we have talked about bar graphs and histographs, and we have also talked about kink. That is, when your data is not starting from 0, you have to put kink, right? So I hope you all got my point in this lecture and you have understood that what is a bar graph and what is a histogram. So thank you for watching this lecture till end. We'll meet in the next lecture.